Good evening, participants, and good evening, sir.
Good evening. Good evening.
To all to this fourth day of faculty development program on advancements in sustainable energy management and environmental protection. So today's speaker for this session one is Professor Ramakarja. It's my privilege to introduce our distinguished speaker, Professor Ramakarja, a highly accomplished academician and researcher in the field of civil engineering. Professor Jha is currently serving as a professor in Department of Civil Engineering at National Institute of Technology, NIT Patna, with a PhD in civil engineering, specializing in water resources from IIT Roorkee. Professor Jha has over 28 years of rich experience in academia, research, and administration. He has guided numerous PhD scholars, BTech and MTech students, and has made significant contributions to water resource management, climate change impact analysis, flood and drought management, and environmental flow assessments. Professor Jha's achievements are numerous, including 7 prestigious awards at both national and international levels. He has successfully led over 26 major projects, published around 200 research papers, authored international book chapters, and established advanced laboratories in remote sensing and GIS. His role as a consultant for globally renowned organizations such as UNESCO, World Bank, and the European Union highlights his expertise on an international platform. In addition to his research, Professor Jha has played a pivotal role in curriculum development, administrative leadership, and mentoring faculty and students. Today, Professor Jha will be sharing his insights and expertise on climate change and energy management, which I'm sure will be both enlightening and inspiring for all of us. Now I welcome Professor Jha to take over the session.
Thank you, Fatima, for giving a very big introduction of mine.
Welcome.
Thank you so much. And dear participants, I'm Professor Jha from NIT Patna. And now I will share my presentation. Let's see. Are you able to see the presentation?
Yes, sir.
Okay, good. So, yes, so this is a training program, and this is a very good topic, which is given to me is climate change and energy management. There are two things. And before I start my talk, I always show one slide, and this is about, you all know this man. Do you know them? Do you know him?
Yes, sir.
Yes, sir.
Stephen Hawking. And you know, he is in the wheelchair. Today's Einstein. He has done a lot of research on black hole. I have two questions to you. Do you know his father? Answer will be no. If I ask, do you know his teacher? Answer will be no. Same is with the APJ Abdul Kalam sir. We don't know the father. We don't know their teachers. So, dear participants, people will know you. People will know you. You are doing for yourself only. Yes, your parents, your teachers are in your heart. But people will know you. So whatever courses are going on, whatever courses you are studying, FDP courses you are attending, this is your life because people will know you. So you are doing for yourself and only for yourself. Whatever you are doing, please do it sincerely, honestly, so you will flourish in your life. Second thing, that was one thing, that people will know you. You are doing for yourself. So this is your life, make it best. Second thing, what is great in him? Dr. Stephen Hawking, what is great? He is not able to walk, he is not able to talk, he is not able to do things. What's great? Mind, brain. preserve it, protect it. Head, your head, head of the family, head of the department, head of the institute, head of the country, and your head is very important. Right? So protect it. All the five senses we do have, all the five senses are here only. Eyes, nose, ear, tongue, skin, all five are here. Head area is very important. Protect it. Okay, so these were the two messages before I start any talk I give to my students, my faculties, youngsters, that this is your life and protect your head. Right? Now we have topic on climate change and energy management. So let's talk separately. First one is the climate change. What is change? What is climate change? What is the difference between the climate change and climate variability? You know, change is permanent. Change is permanent. What you were looking 5 years back, you are not the same. And after 5 years, you will not be the same. That is a change. Change is permanent. Climate change, temperature rise, rainfall increasing, rainfall decreasing, weather is changing, and if it is changing continuously. Another example I'll give you. Variability, climate variability. Suppose you wake up early in the morning. I know many of you don't, but I suppose that you wake up in the morning at 5:30. But you don't wake up every day at the same time. Sometimes 5 minutes before, sometimes 5 minutes afterwards. So this is a day-to-day variation. On an average, you are waking up at 5:30. That is climate variability. If today it is raining, tomorrow it is not raining, it is not the climate change. It's climate variability. So be careful when we are talking about the climate change and climate variability. In 1 year, we may see a lot of climate variability. But change is a long duration activity. And here you see it defines that change is refers to long-term shift in temperatures and weather patterns. It may be a rainfall, it may be a wind, it may be a humidity, it may be temperature and other weather parameters. Right? It's very important for us to differentiate between the climate change and climate variability. It is a natural phenomenon. As I told you, what I was looking 10 years back, 20 years back, when I was child and when I'll be old guy, it's totally natural phenomena, natural decay process, natural upgrading process. These are all phases of life, natural. But nature, the hilly areas, the rivers, the nature, the flowers, the ground, everything is very beautiful. Groundwater, surface water, beautiful. But it will decay with time. It will get older. It will have a weathering effect. Air, rain, high temperature, everything is going to affect our skin, our body, all the living things. That's a natural process. Moreover, what we are doing, we have some anthropogenic activities, human interventions. We are giving human interventions, and that is creating problem. That is adding, means what? A child, a man, human being grows up and becomes old. It's a natural process. But two children, one is living on the street, one is living in air conditioning, and one is living in normal house. They all will, with the same age, will look different. Right? Because they have anthropogenic impact of the system. They are not getting good food, their hygiene is not good, and so many things. They look much older who are having the good hygiene, good food, and good environment. So that is anthropogenic activity. So whenever we are talking about the change, climate change, it is natural as well as the human interventions, which we call it anthropogenic activities. Right? Now, let's get into details. Human activities. What really activities we do? We do agriculture, we do industry, we do the transportation, we do the heating, we do the fossil fuel burning. All these things are because now in winter in Patna, in Bihar, we have a lot of cold. So you go outside and people are burning the woods, coals, and that is the fossil fuel. We are burning it. So these are the human activity. And if I say human activity, what happens? We are releasing carbon dioxide in the atmosphere. We are releasing methane in the atmosphere. And you know, in winter, many people use the heaters, blowers in their room, and the room is closed from all the sides. What happens? Because of this human activity, because of the heating, what really we are doing? We are killing the oxygen, and that transforms into carbon dioxide. And further, because carbon dioxide is having CO2, two oxygen contents. So what really it happens with time, it transforms into carbon monoxide, CO, and people die in the room because of the lack of the oxygen in the room and because of the human activities. So this is in a longer term, if I will say this is a climate change process. And another one is land use, land cover changes. How we are making the land use, land cover changes? We are having a lot of urbanization. So for urbanization, we are reducing agricultural area. We are reducing the forest area. So we are doing deforestation. We are really impervious surface because urbanization, we will construct road, we will construct buildings, we will do so many things like that. It means what really we are doing? We are playing with the nature. We are changing the land use, land cover pattern. And as a result, what really we are doing? We are becoming carbon poor country. Carbon rich country we are not. We are reducing the plants, we are reducing the coal, we are reducing the natural resources. So that is causing greenhouse effect. And we will see that also, what is really greenhouse effect. In the coming slides, we will see, because it is very important for you to understand the climate change, climate variability, human activities, which is causing climate change processes. And once it is done, it is really creating carbon dioxide, carbon monoxide, and other greenhouse gases. Because we are more advanced, we want to go for urbanization and compare ourselves with developed countries. But we are really not looking for the carbon, prevention of the carbon, means plants, trees, right? Now, climate change, once we saw climate change processes, what happens then? Greenhouse gases, what it is doing? You are finding these are the different characteristics. We are finding that ice is melting. What really we are finding? Average temperature is rising. Precipitation pattern is changing. Rainfall pattern is changing. Earlier, I remember during our childhood, we used to find that the rainfall is spreading over the 2 months, 3 months, 4 months. For 1 week, for longer duration, we were not able to see the sun. But now, the precipitation rainfall is like that, like a Zomato and a Swiggy. It comes, it gives you delivery, and it goes back. It is just like that only. It is raining, coming, raining, intense rain, and it goes. We don't know from where clouds came and how it rained, and it is going back. So it is just like becoming a modern, as we are changing our behavior, as we are changing our day-to-day habit, as we are more fond of fast food, the nature is also changing. Precipitation is coming as a Zomato or Amazon and giving you delivery, and raining and going back, right? So change in precipitation pattern. Clouds, they are changing. Ocean circulation, it is also changing. We say that we are going to have water scarcity. Why? Why we say the water scarcity? We have water. Then why we say? We have a lot of water in the ocean. It will go to the groundwater. It will evaporate. It will rain. It will again come to us. It will go to the ground. It will go again to the sea. So it is a circulation. Then how we say that water in Hyderabad, there is no water in the Deccan Plateau? Why we say that? Because we have changed the cyclic pattern. We are exploiting more. If I am getting a salary, I am knowing that I am going to spend 20,000, 30,000, 40,000. Next month again it will come, it will follow a cyclic pattern. But if it becomes abrupt, it becomes irregular, then we have scarcity, because we are withdrawing more money than what is going to bank account. That is the problem. That is the main issue we are finding with the change in precipitation, ocean circulation, and abrupt climate change. That is causing abrupt climate change. Every water is going to sea. River is flowing with fresh water. A lot of ponds are there. A lot of wells are there. They are having the water. And when it goes to the ocean, it becomes saline. So everything is changing. Water, even water temperature is also. So from human interventions, we are finding greenhouse gases as a result. And from greenhouse gases, we are finding this is the total changes. Same is applicable to human being also. If you eat, if you are not taking care of the head part, you are eating something bad, then it will have effect on your stomach. If we lose 60% of our energy through our eyes, whatever we like, we just try to see it closely. We 60 to 70% of our energy we are losing through our eyes, and that will affect our brain. That will affect our food habit, because if you are doing a lot of work, all the blood comes to your brain and stomach indigestion starts. So human activities is causing problem in the full body system. Same is with the climate change. When we are talking like this, so then what is the threat? I will have problem. I will have corona issue. I will have HMPV virus has come recently, and so many health diseases. First is stomach is upset. 90% of us are having stomach problem. Why? Because we are not taking care of his head. We are giving human activities, taking whatever we like, our taste, and that is creating whole problem. Blood pressure, then we have the sugar, we have the knee problem, back pain, stomach problem, kidney problem, and blah, 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 so many things. So these are the threats. When we talk of the climate, these are the threats in the climate. What? Sea level rise. Many places, many cities are going to vanish and they will go inside the sea. Disaster spread means lot of casualties, lot of hazardous famine, lot of economic losses. These are different type of disasters. Loss of traditional livelihood and biodiversity. Everything is going to change. Everything is going to change if there is a climate change. And if we are not careful, each of us are equally responsible. As everyone is responsible for their health, now I'm finding many participants here, 60, 70. Each one of you are responsible for your health. If you make any human interventions, any human activity which is not natural and which is going against your health, good health, you will have to face it. Maybe some of you are having some issues. So when we combine this is, I showed you from a human intervention here, then human activities to climate change processes, and then from their main climate characteristics, and finally major threats. It's very important for all of us to be awake. Each of us are equally responsible, and we have to make proper mechanism, management to reduce this climate change variability. Some examples I have shown you here. And I will give you one example also, which we have done in our institute in recent past. Here you see floods, especially in the northern part of India. You can see Bihar, Bengal, Odisha, Maharashtra, Gujarat. They are facing a lot of flood problems these days. Even Rajasthan has started facing this problem. Many casualties. And this is not only a problem of flood. We find that when the flood recedes or water remains over there, lot of health issues, medical issues are coming up. Same is with the drought. What is the difference in flood and drought? If there is a climate change, as I told you, suddenly rainfall is coming, huge amount of water is coming, and we call it cloud burst. In hilly area, if the cloud burst is there, what happens? If there is a cloud burst in hilly area, water comes with the lot of sediment. Very simple thing I want to tell you. If an elephant is falling from the hilltop, and if a mouse is falling from the hilltop, if an elephant is falling from the hilltop and a mouse is falling from the hilltop, which is going to give more impact? Of course, elephant. Why? Because it is having mass into velocity. Both are coming with the same velocity from the hilltop. But elephant will give you more impact because it is not having only mass into velocity momentum. It is having mass into velocity per unit time, mass into acceleration, that is force. And that force of elephant is going to vanish everything. When there is a flood, and flood is because of the cloud burst, huge rainfall, which is coming, and that is coming on the earth in the hilly area, and the water starts flowing, it will take lot of sediment with it. And it will not have only momentum effect, mass into velocity, but it will have mass into velocity per unit time, that is mass into acceleration, that is force. And that will vanish everything. Many villages vanishes because muddy water is coming. It's not only flood water. That is the problem. We have to understand the fundamentals. Head should be strong. Make your head very strong. This is your life. People will know you. Then comes the drought. That is also because of the climate change. And this drought comes very slowly. Like food poison. Like we eat every day, we are eating fast food, junk food every day because we don't have time. And if we don't have time, we go to the market, we buy and we eat. I don't know what we are eating, whether it is 2 days old, 3 days old. When we come to know? After next morning. When we come to know? At midnight. When we are feeling uncomfortable, feverish, vomiting, loose motions, everything. Drought is like that. Immediately we will not have any. Immediately it looks very good. Oh, drought. But it comes after 10 days, 15 days. No rain, no rain, no rain, no water, nothing, nothing. It is getting dry because of the climate change. And result comes after 15 days. Same is with us. Nowadays, we are more concerned for time, no time. I have no time, no time, and like that. And that is a drought. So you should be very thorough. You should understand the fundamentals. Don't mug up the equations. No. You must understand what the change is, what the climate variability is, what really we are talking about the floods, what really we mean by floods. Very simple example I'll give you, then I'll come to this slide. Flood. I'm hungry in the morning. I wake up, I am hungry in the morning. I eat a lot, right? I am eating a lot. Then in the daytime, I go to office I took my lunch, I take it, but some students came, sir, I have brought this samosa or this idli and vada way for you. I will eat it. Then suddenly after at 4 o'clock, someone came, sir, this is a very, I prepared at home dosa. You please have it. I ate it. And like that, I ate, and tea and drinks and coconut and everything I have started taking. What will happen to me? In the evening, I will have two situations. One is I will vomit. The second one is my stomach will be upset. So if I vomit, that is flooding. The soil is hungry. In Hyderabad, soil is hungry. In the monsoon, when the first monsoon comes, it will take breakfast, everything go in. Then in the afternoon, everything will go in. As soon as July, August comes in, little rain will cause flooding because the stomach of the soil is full. The stomach of the soil is full means it is flooding. And if it is flooding, it will create hue and cry. Anywhere in the world, globally, you go and see when the flood comes. It will be in August, September, or October. Yes, please. Anybody wants to know anything? Is it okay?
No, sir, please continue.
Okay, fine. So that is the thing. You have to understand what the flood is. And soil is hungry, soil is full of stomach, and then it is vomiting, and that is flood. Similarly, snow melt. Today, I may not be able to show you one slide, but it is showing that the glaciers are melting. The snow is reducing. Sea level is rising. Temperature is increasing. I see they say that temperature is increasing by 0.5 degrees, 0.3 degrees. Why? What is the meaning? 3 degrees, 0.3 degrees, it has no meaning. It has. Why? Because we are talking of the extremes. If temperature is 1 degree and it becomes 0, you will find ice. If the temperature is 49 degree, it becomes 50 degree, it will be burning. When each of you, many of you might be making tea at home, right? I also do it in the morning. I make tea. Now, as soon as the water boils, starts getting heated and then boiling, what happens? Its temperature goes up to 50, then what happens? Oxygen reduces, water evaporates. Yes, that is the impact of climate change, temperature. We are talking of the peak values, maximum values. You take example, every day you are doing it, making tea, you are going to tea shop and he is making tea or she is making tea. You are observing it. As soon as it boils, oxygen gets reduced. High temperature, oxygen will be less. You will find lot of evaporation. Hot water is coming out. Everything is climate change. You think that the teapot and the water is the nature, is the hilly area, is the snow area. And if the temperature rises there, same situation will be there. Okay? So that is the importance. Fundamentally, if you are clear, if you understand this with the human analogy, what happens to my body system, how it behaves, and what is the nature, then you will not have any issue. And then you remember the equations and go and appear in the exam and you will do wonderful. But if you are not fundamentally clear and you are mugging up, then you will not. Now you can see here in India also, rising mean sea level because of the climate change. This situation may take place if we are not careful. Right? And this is the temperature. Over last century, how it has been increasing. The temperature has been going up in the last century. Now comes the global climate change over the last century, and this is showing some numerical values, and this is not done by me, this someone has done it and I am reporting only. But this is an information. This information may be of help to you when you are planning for the city, you are planning for your campus, you are planning for your home, and you are planning for the society. You have to know this information as a background information, right? So this is showing that how the temperature is increasing and how it has been changing with time. Some graph is shown over here. You see here, it is increasing. Line is showing increase, but you see each bar chart, it is showing sometimes up, sometimes less, sometimes more. So that is a variability. But the trend is long term, right? What I wanted to tell you, the change and the variability, I think you have understood. And this whole area, you will see this, that how the temperature has been varying at different places, less and more, and which are having the red signal. It is indicating what it indicates. It is giving you the temperature and the rainfall pattern of the all over India. You can see here, this is also showing you the, now we have to predict, we have to go for modeling, because we have talked so much about the climate change, variability, and then the greenhouse gases, how, what is the cycle and how it is going to affect. And I gave you example of the human analogy, how we behave. I gave you example of it, making a tea. Now, future 2030, 2040, 2050, what we are going to have, we have to predict it. We have to see what temperature will be approximately after 50 years, 20 years, 30 years. Rainfall, what will be the rainfall after 20 years, 30 years? Why? What will happen to your children? What will happen to your grandchildren's if you are not thinking so? And if you are not giving answer to this, why? I tell you all 60, 70, how many participants you are and the organizers. Let's all go to a hotel in Hyderabad sometimes when I am there, and we all will eat for 2 days. Whatever you want, you eat. Vegetarian, non-vegetarian. But I will not give you water to drink. Whatever you want to eat, you eat. I will not give water to drink. Also, I will not give you water to wash your hands. Use tissue paper, use milk, use oil, use juice, use dal ka pani, use sabji ka pani, use whatever you want, liquid you want to use. But I will not give you water to wash your hand and not give you water to drink. What will happen? This is the importance of water. What will happen to your next generation, your children, your grandchildren? For that, we have to go for futuristic analysis, modeling, and there are many global circulation models. What is a model? It is not that model what we are seeing in the movies and all the fashion shows. Modeling is for prediction. What is model? Model y is equal to mx plus c. Is a very simply straight line equation. Y is equal to mx plus c. Each of you have done it. Y is dependent, x is independent, m is the slope, and c is the coefficient. Intercept, we call it, right? If c is 0, it becomes y is equal to mx. M is the slope, x is independent, and y is dependent. Now, this is a very simple linear model. We want to represent something independent with the something dependent, right? So that is very important. We have so many general circulation models available globally. Now it is available. Every scientist is using. Many of you are also doing on climate change model, and you are downloading, downscaling, and using it, and blah blah blah. So many things you are doing it and predicting. But which one is most suitable for India? Which one model is most suitable for our region? Andhra Pradesh, Telangana, which one is more reasonable method? What really you will do? You will use the observed value, what is being observed, temperature daily variation, and the rainfall daily variation, and then you will compare with the different models available for India and for Telangana and Andhra Pradesh. You will try to compare that. Okay, this model is giving this kind of trend, actually observed values during that period. Then this model is giving this kind of result. My observed values are like this. Okay, the out of 13 or 14 or 100 models, these 2-3 models are most suitable for our study area, and I will do the future projections using that. This is what we also did for our study. I'll show you. Yes. When we talk of the general circulation models, we have so many things to consider. It considers there are satellite data and they are taking every day, every minute, and they are doing it. There are different models which are available, around 40 models. Many big scientists who are basically physics background, and they are using the physical laws of the nature. You will ask me, what is the physical law of the nature? How you walk. We walk by Newton's third law. Every action has its equal and opposite reaction. We walk fast, run fast. We try to push the earth very fast. You might have seen the fan. Always it is rotating like this, ceiling fan. Why it is not changing its direction whenever I do it? Why? You all have studied that. Why fan whenever if I put a ladder, it will stop, and again I start, it will rotate like this only. Means anti-clockwise. If you just put it this way, you will find it is anti-clockwise. Why? You all have studied Fleming's left hand rule. Current from top to bottom, left to right is the magnetic field and the direction of flow. Right? So we are governed by the law of the nature. And the physics people might have used different natural phenomena, climate, wind speed, temperature, and so on. Okay, some children is there. Please switch off your, mute your mobile, this speaker. So now there are different models, right? And these models, we have to apply for Indian condition. We did it for, and then they are having this, you go through that, there what is SSP, what is RCPs, when we are using the climate models. And you can apply these data for Indian conditions, which we did, and we found that 13 climate sensitive models are very useful for India, for whole India. You can also try one of these models for Telangana and the Andhra Pradesh and Tamil Nadu and the neighboring states, everywhere, all over India. You belong to which place, because charity starts at home. So you can start over there and you can do a lot of work. You can find out of these models, all these 13 models are suitable. They are bias corrected and they are suitable to assess the climate change and future projections. So out of these 13, you can find that which one is giving me the best result, and then you can do the future projection. We also did for this region, the northern region, and we found that these are the results. Just I wanted to show you, these are the results, and we can really do the future projection. You see here, mean rainfall, how it is going. It is showing that in 2099, 2075, 2078, it is going to increase. Trend is increasing. It may have the variability annual, but trend is going to increase. Rainfall is going to increase. You can see here. It is going to mean monthly rainfall is going to increase. Annual rainfall is going to increase. Similarly, here you see that how it is going to projected one. So with that, I can plan for Telangana. I can plan for Andhra Pradesh, I can plan for Tamil Nadu, I can plan for Karnataka, I can plan for any place based on this, that what should be the planning to save living things, including human, livestock, and the plants. Based on this information, rainfall, temperature, wind speed, everything we can do the calculation, and we can plan storage, storage phenomena, how really we can do it. Maximum rainfall is also going to increase. So as I told you, it is just delivering like a Swiggy or the Amazon and going back. So maximum rainfall is also going to increase, right? So we have to really make proper arrangement for its storage, water storage, because that is, as I give you example, we all can go to hotel, but you will not be given water to drink. You will not be water to wash your hands. Use anything you want, juice, oil, milk, anything you want, tissue paper, but water will not be given. This is the importance. Now, greenhouse effect, as I told you, we have done a lot of work on greenhouse effect. I have been teaching this course to my students. Greenhouse gases are very important, and it is coming out from the air conditions, it is coming out from the cars, it is coming out from the fossil fuel burning, it is coming out from the this from the reservoirs, water storage, methane is coming out, all these toxic gases are coming out, and they are going to the atmosphere. What they are doing? They are making hole in the ozone layer. What they are doing? They are making hole in the ozone layer. Means what? You see that in the summer, in the hot weather, if I keep my car outside, what happens? In the daytime, when you open the car, it is a burning. It is just like burning. What happens? The short wave radiations which are coming here are transformed to long wave radiations, and it is moving inside the car only. It is moving inside the car only, and it is becoming a thermal effect. It is giving you very heat island. It is just behaving like a heat island. That is greenhouse effect. And you please observe, during cloudy day, it is warmer because of the greenhouse effect. Why? Going up and coming back. Short wave radiations have penetrated. It has come to Earth. It is going back, but it is transformed into long wave radiations. And then it is keep on moving here up and down because of the clouds, because of the greenhouse gases, because of the pollution. A lot of pollution is in Delhi. You are listening every day. Huge amount of pollution. It is smog, lot of itching in the eyes. Why? Short wave radiations are transformed into long wave radiations, and we are getting greenhouse gas effect. It also makes hole in the ozone layer. And in many countries, you are finding, because of the greenhouse gases which are making hole in the ozone layer, is causing cancer. Because nature is beautiful. Nature is wonderful. Why? Many rays which are harmful, X-rays, alpha, beta, gamma, ultraviolet, nature is not allowing that to come to Earth. If you study the remote sensing and GIS subject, you will find the nature is not allowing many rays to radiations to come to Earth, and ultraviolet rays are one of them. But because of this greenhouse gases, if there is a hole in the ozone layer, ultraviolet rays will penetrate and will come to to Earth, and that will cause the cancer, skin cancer. That is why in summer we say our students, our faculties, please don't go out, don't live in the sun for longer duration. It will not only make your skin black, tinting, but it will also create skin cancer. It may create skin cancer. If there is a hole in the ozone layer, ultraviolet rays are coming to the earth and you are getting affected with that rays, it may cause skin cancer. So be careful, right? This is the greenhouse gases and we have to reduce it. When we will talk about the energy efficiency, there I will tell you some of the things. Really, we have to reduce the greenhouse gases. And how can we reduce it? That we will see over there. It's very important. It's really very important for all of us. If we want to save ourselves, we have to do it. It is coming up and going up. It is coming down and going up. It is absorbing and radiating. You know, the dark color, black color, we always say in summer we should wear light color. We should not wear dark color. You see buffaloes, you see the black color things. What happens? In our home also, we are using iron pan, right? For making roti. We are using iron pan for making sabji. Why? Because it absorbs, and when there is no flame in the gas, it radiates. That's why we find that our food is preserved for longer duration over there. It remains heated over there. It remains warm over there for longer duration because it radiates. So black color, that's why we are finding that we are using black iron pan, right, for cooking. And black color absorbs and then later on radiates, right? So greenhouse in the Andhra Pradesh, you might have seen in Hyderabad now, in the Telangana, we are observing lot of fishes. NRSC, National Remote Sensing Center, what they do, they forecast the fishermen at 4 o'clock in the morning that sea surface temperature will be like this, and fishes are found at a particular location at a particular temperature. All the fishermen are going, and all over India fishes are coming from that area only, Andhra Pradesh, Telangana only. You will find everywhere this Andhra fish, everywhere you will find. This is because the temperature, sea temperature, at particular temperature fishes are observed, and satellite data is giving you the value. Because of the radiation, why I'm telling you all this example? Radiation. At night, it radiates. There is no sunlight and it radiates. That's why they forecast in the morning. They take the surface temperature in the absence of sunlight from the remote sensing and they give you the values. Now, we have this theory. I will not tell you because these are so many things. We have mean constituents, atmosphere, and how they are behaving. This part I will skip because this is a important greenhouse gases. So you can see here, and then comes how it behaves, carbon dioxide, methane, N2O, and sulfur dioxide, how it is behaving. It is giving a different, this presentation I will send, and any of you want more about the greenhouse gases, because I have some more things to tell you about the aerosol and then finally energy efficiency. So I will skip this. These are the greenhouse gases, different how they are affecting these equations, what is the climate forcing, everything is explained here. That is not, they're not required. But why certain gases interact with radiation, like methane, water, CO2? What happens? When there is a radiation coming up, it can excite the molecule either by vibrating or rotating. Molecules of a particular kind of gas have different shape, so that they vibrate and create lot of issues with the human being, with the atmosphere. And this you can see here, example is given. So I will not explain this as well. You can very well see it. Now this is the thermal structure of the atmosphere. You can see that how the thermosphere, mesosphere, stratosphere, and troposphere is changing as we go up altitude. And as we go to the hilly areas, you can go to Tibet and any other places, Himalayas, you will find lack of oxygen over there. So different atmospheric pressure is there, and the pressure is working on the atmosphere and in our body, human body also. That is really causing the climate change. This I will already explained you. Now, physical impacts. So it has a different physical impact on climate change. We already discussed everything about this. Social impacts of the food system, health, water resources, migration. You know, in desert, Sahara desert, people migrated because of the climate change. Temperature has gone extreme value, 49 to 50, 50 to 51, 51 to 52. No one can live over there. So they have to move. Aerosols, they are again very important. You know, you are using deodorant, that is aerosol. It is having oxygen, it is having nitrogen oxides, ammonia, organic compounds. So that is aerosol we are using in our deodorant. That is also in the atmosphere, and that is helping to reduce the greenhouse gases. We are having this aerosols in the atmosphere also. So we should be really working on having more aerosols and less greenhouse effect. What will happen? That will reduce the impact, and it will reduce the hole in the ozone layer. This again you can study in your remote sensing when you are doing it, how small particles and different kind of scattering is taking place in the atmosphere, and how useful aerosols are. And I give you example of the this aerosol is a deodorant. Ozone layer, O2, O3, sun, because of the sun, it is a cyclic O2 and O3. And we have to have more ozone layers in the atmosphere if we want to protect us from the ultraviolet rays, X-rays, alpha, beta, gamma rays, because that is very dangerous for human being and all living things. So ozone layer is very important. And remember, now when we talked about the climate change, we discussed about the climate change. We have seen the global circulation models. We have seen the greenhouse gases. We have seen the aerosols. And now we are saying that if we want to protect the climate change, we have to have more ozone layer, so that it less greenhouse gases, more aerosols, and maximum ozone layer over there. Ultraviolet light, I told you in the remote sensing, you will study, you will see that nature is protecting us. Nature is beautiful, it is wonderful, and it is protecting us from the UV rays. Nature is having the layer of the in the atmosphere. Now, after doing this, we found that when I was talking about the climate change and its components, the energy management is really very important. We are least bothered, and you will find when the winter starts in Delhi, people start talking about the parali, burning of fossil fuels, burning of the paralis, means husk. This stem we are finding from the rice, they are burning it, and that is creating a lot of problem. So energy management is very important. We have to be carbon rich country, and that is possible if we are doing energy management. That will save really climate and save our life, our next generation. Like I gave you example of the water, it is very important. Now what really we have to do? Reduce fossil fuels. It means we have to reduce the burning of fossil fuels. We have to go more on renewable source of energy, solar system, hydropower, windmills, 3, solar, hydropower, and wind. It does not need any, sun is giving us light full day. Do you pay any money to sun? But if you will use 100 watt, 10 watt LED lamp bulbs, your electricity bill comes. But sun is giving you light day and night. In daytime here, nighttime it will be daytime somewhere else. Do you pay energy bill to sun? Why you are not using? You are using fan. But when there is a wind, are you paying for that wind? Oh, बहुत अच्छी हवा चल रही है. Do you pay? No. So it's nature's gift. Hydropower, you drink water. You will go to a fountain. You'll, oh, very nice. I'm getting fountain water. It looks, if you any garden, you go, you will find fountain. You start living over there close to the fountain. You enjoy for it. Nature, it is raining. Do you pay for it? No. So we have to go for renewable source of energy and reduce the fossil fuel. 3 things: solar, wind, and hydropower. Right? Energy efficiency. How? We have to go for green buildings. Green buildings means what? We have to have renewable source of energy. We have to have a waste management. Whatever waste is coming, generate energy from that. Whatever human waste are going, human waste excrete, urine, generate energy from that. STP. You recycle, reuse, use it, that water for treated water for gardening. So improve the energy efficiency. Use renewable energy. Modernize infrastructure, green building, as I told you. So we have to have power lines, pipelines, and everywhere we need to really work hard. Cables, earlier we used to have high voltage, high power cables were going, lot of energy were lost because someone is going close to that high tension wire, they will just go and stick on that. They will die because it was having lot of area which was having the magnetic effect, electrical effect, and that was creating problem. Ensure energy equity. You are finding those who are not getting, cost is very high, they are using illegal way of making the energy, using it. So make it proper. We can use local infrastructure, and these are some of the things I think if you are able to do only one, that is renewable source of energy, all the 3 second one is the infrastructure development, local development. We reduce the expenses, we reduce the energy, electricity or the fossil fuels by having the local infrastructure, or third one is the green building. So these 3 things if we are doing, one is the renewable source of energy, it has 3 components: solar, wind, and solar, then the wind. Third one was hydropower. That is one thing, we reduce it. Second thing, we can use local material, local mechanism, so that we can reduce the use of electricity, transportation, fuel, and everything. Right? And what was the third one? We can really look for the how we can make it more efficient buildings, green buildings. So in a structure, 2 things. One is the green building, another one is the local material you use, and third one is the use renewable source of energy. So this will really reduce its impact on the climate change, and it will really give you you can make a good connect between the climate change and energy efficiency. The topic was very relevant for today's, and I would like to thank each of you who were here and who listened my talk. It was really wonderful. These are some of the things. Germany, they have done a lot of work on this. They have done. In India also, we are coming up, and I am expecting that each of us can really do it. So, so many things which are in addition to what I discussed now, that we can go for our governance, health, education, demographic, and everything we can really think of that. So now I am going to end up. I have done so many projects with international people. I got ASA awards and all. These are the things which are I have done so many projects in India as well. I'm involved in, and then these are the my news. I'm coming frequently in the news for live programs, so some of you can also join sometimes. So that's all about my talk, and if you have any question, please ask me. Feel free to ask me the questions. Yes, please. Fatima, I am, I think, done. Any of you have any question? I'm finding good number of people joining here. So if any of you have
Dear participants, if you have any queries, you can please ask your questions.
many participants are giving thanks to me in the chat box. But no one is asking any question to me. I think either they have understood fully or they have not understood.
No, so it was very engaging and interesting session. Once again, request the participants, if anyone would like to ask any question, so is ready to answer.
Okay.
So we'll take it as no questions then.
Yeah, thank you. Thank you. Okay. So should I close now?
Just a minute, sir. Let me check. So once again, good evening to one and all. As we come to the end of this insightful and thought-provoking session on climate change and energy management, it's my honor and privilege to propose a vote of thanks to our esteemed speaker, Professor Jan. On behalf of Maulana Azad National Urdu University and the organizing team of this faculty development program, and all the participants, I extend our deepest gratitude to Professor Jha for delivering such an enlightening session. His deep knowledge with decades of experience in the fields of water source management, climate change, and sustainability has given us a fresh perspective on the climate critical challenges and opportunities surrounding climatic change and energy management. We are immensely grateful to you, sir, for sparing your valuable time to be with us today and sharing your expertise. Your session has not only explained our understanding, but also has motivated us to take proactive steps towards a more sustainable and resilient future. Once again, I thank you so much, Professor Jha, for your invaluable contribution. We look forward to having you with us again in the future. Thank you, sir. Thank you so much.
Thank you. Thank you so much. Thank you so much. Okay.